Now we're going to talk about probability. Okay, now what's probability? Probability is just all about estimating how likely something is to happen. Okay, how likely something is to happen. Okay, we normally use it to predict. Okay, normally used to predict. Okay, now if probability of anything happening at all, that's a full probability, is 1. Okay, that's when you're sure the thing is going to happen, is 1. Now probability of something not happening at all, when you're sure it's not going to happen, is 0. Now probability it will happen or not, that's two sure chances of whether it's going to happen or not, is half. For example, if you have a coin now and you want to throw it up, you know a coin has a head and a tail. Okay, now probability that a head will come up when you will show when you throw it is half, and probability that a tail will show is half. Okay, now in probability, if two events are independent, okay, the outcome or the result of one doesn't depend on the other. Okay, just the way independence means. Okay, if you're independent, you don't depend on another person. Okay, so if two outcomes are independent, or if two events rather are independent, outcome of one doesn't depend on the other. Okay, they're not dependent at all. So if okay, for example, now if I throw up two coins, okay, now getting head in the first coin will not affect probability of getting head in the second coin. Okay, or getting tails in the first coin, it will not affect probability of getting tails in the second coin. Now these are independent events. Okay, now we also have something we call mutually exclusive events. Okay, now mutually exclusive events are events that cannot happen at the same time. Okay, that you're very very sure that two of them cannot happen at the same time. Two events that cannot happen at the same time. Okay, these are mutually exclusive events. Okay, now for example, if events A and B are independent, okay, probability of event A and event B happening is equal to probability of A times probability of B. Now notice that if it's and, probability of this and this happening, there is times there. Okay, now when two events are mutually is exclusive, and B are mutually exclusive, okay, probability of A happening or B happening is the same thing as probability of A plus probability of B. Okay, now or has sign of plus and has sign of multiplication. That is one of the greatest rules of probability you have to remember. Okay, now some other thing we have to talk about is conditional probabilities. Okay, what's conditional probabilities? Conditional probabilities are those probabilities that occur when one event depends on a previous event. Okay, are probabilities that occur when one event depends on another or on a previous one event. Okay, now for example, let's take questions on probability. Okay, Now we're told that there are some ribbons in a box, and the ribbons are green or red or yellow or white. Okay, and that the table shows the probabilities that a ribbon chosen at random will be green, red or white. Okay, and that's this table. Okay, now we are told to work out the probability that a ribbon chosen at random will be yellow. Now this is one of the simplest forms or examples of probability. Why? Because we already know that the full probability of an event occurring already is 1. Okay, since we have of green 0.15, red 0.30, white 0.35, we just know that this yellow is going to be 1 minus additions of all this. Okay, that's 1 minus probability of green, this is a full bracket, plus probability of red plus probability of white, then you have your probability of yellow. Okay, probability of yellow is 1 minus all these other probabilities. Okay, now you're going to have 1 minus 0.15 plus 0.30 plus 0.35, and that will be 0.2. So probability of yellow being chosen is 0.20. Now another thing again we'll ask is that there are 500 ribbons in a box. Work out the number of red ribbons. Now we're told that probability of having red is 0.30. Since that's the probability, number of red ribbons is just 0.30 times 500. Okay, you have 0.3 times 500, that's 150. So we have 150 red ribbons. Okay, now the reason why we multiply it out is probability of red actually occurring is 0.30. So it gives us an idea of how many the probability, okay, that will probability of the number of reds, okay, that we have in that box. Okay, now let's have another probability question. We are told that there are 11 buttons in a bag. Okay, 7 buttons are white, 4 buttons are black, and Harley takes a button at random from the bag and keeps it. She now takes another button at random from the bag. Okay, work out the probability that Harley takes a button of each color. Now this is our example of conditional probability. Now she picks one, okay, and keeps it, and then she takes another from the bag. Okay, now we're now asked to work out the probability that she takes a button of each color. Okay, now this is also a combination of our mutually exclusive and independent probabilities. Okay, now we're told that there are 11 buttons. Okay, now she now selects 7 buttons. Okay, no, there are 7 buttons are white and 4 are black. Okay, she now takes a button at random and she doesn't replace it, she keeps it. Okay, so for each time she takes a button, the number reduces. Okay, and she now takes another button at random from the bag. Work out the probability that she takes a button of each color. So the probability is either that she takes white, black, or that's white and black, white and black, okay, or black and white. Okay, they're just 2 colors, so they're just asking the probability that she takes 2 of them. Okay, now remember that when she takes the first one, she doesn't replace it. Okay, so the total number reduces. Now there are a total number of 11. Okay, probability of white is 7. Okay, or the number of white 7, and then the number of black is 4. Okay, now for white black we have, for white, now the total of this is 7 plus 1, that's 11. That's 11. Okay, now probability of taking white from there is 7 over 11. You have 7 over 11. Remember, when you see and, you multiply. Okay, so times probability of taking black. normally if she replaced it, it would have been 4 over 11, but since she had already taken 1, the total will remain 10. So this one will now be 4 over 10. Okay, or will become plus. Put another bracket. Okay, probability of taking black now. Okay, now this is another start. This is either she picked this way, white and black, okay, or she picked black first and then she picked white. Okay, now for black, now probability of taking black is going to be 4 over 11 if she took black first. Okay, now this one is if she took white first, this one is if she took black first. Probability of taking black now is 4 over 11. Okay, that means the total will now remain 10. Now probability of taking white will now be 7 over 10 times 7 over 10. Remember, this is and, so it's times. So you have 28 over 110 plus 28 over 110. So you have your 28 times 2 is going to be 56 over 110. This is 110. Okay, when you cancel out, we have 28 over 55. Okay, now this is what you're going to get. Now let's solve another question that looks similar to this too. We have another question that goes this way. Phil has 20 sweets in a bag. Okay, now 5 of the sweets are orange, 7 are red, 8 are yellow. Now Phil takes at random 2 sweets from the bag. Okay, work out the probability that the sweets will not be the same color. Now we're told that there are 3 colors. There's orange, there's red, and there's yellow. So if Phil takes 2 sweets from the bag, it's either he took orange. Now we're going to represent orange with 0, red with R, and yellow with Y. Okay, it's either he took orange and red, okay, or he took orange and yellow, or he took red and yellow. Okay, now after having this, now let's write down all the numbers of all these ones. For orange is 5, for red is 7, and for yellow is 8. Remember, they said pick at random 2 sweets. As he picks at random 2 sweets, work out the probability that the sweets will not be the same color. So that's why we're mixing them up like this. They are not the same color. That the 2 he's going to pick. Okay, now it's either he picked orange and red, orange and yellow, or red and yellow. Okay, now having written this way, we're now going to start calculating probability for each of them. Now adding 5 plus the total. Okay, total outcomes, or the total, is going to be equal to 5 plus 7 plus 8, which is going to give us 20. Okay, the total number is 20. Okay, now probability of picking orange. Now assuming he just picked orange and red, what's the probability of picking orange? The probability of picking orange is 5 over 20. Now and is times. Okay, this is probability of picking orange and red. Okay, now probability of picking red now is supposed to be 7. Okay, now it's 7 over, but we've already selected one and we're not told that it was replaced. Okay, now since we selected one, that means this total has reduced to 19. Okay, now plus probability of picking orange. Now assuming he picked orange and yellow and not orange and red. Okay, probability of picking orange is 5 over 20. This is total. Now times probability of picking yellow is 8. Okay, so we have 8 over, but the total has changed because we picked one before. The total changed to 19. Okay, plus now probability of picking red is 7. Okay, 7 over 20. Now times, because it's and, now probability of picking yellow is going to be 8 over 19 because 1 has already been picked. Now let's find that out. We have 5 times 7 is 35 over 20 times 19 is 380 plus 50, 4 times 5 times 8 is 40 over 380 plus 7 times 8 is 56 over 380. So we have this to be 56 plus 40 then plus 35. We have 131 over 380. Okay, now this question says Phil has 20 sweets in a bag. Okay, 5 of the sweets are orange, 7 of the sweets are red, 8 of the sweets are yellow. Phil takes at random 2 sweets from the bag. Work out the probability that the sweets will not be the same color. Okay, and they will not be the same color. Okay, now we are told that there are 5 of orange, now 7 of red, and 8 of yellow. Okay, now to do this we're going to work out the probability of picking orange and probability of not picking orange and not orange. Okay, because we're saying probability that 2 will not be the same color. Okay, now plus red and not red, now plus yellow and not yellow. Okay, that's probability of this, and probability of this. Okay, now probability of picking orange now is 5 over this total. Now the total is 20. Okay, probability of picking orange is 5 over 20. Okay, probability of not picking orange, now the total is 20. 20 minus 5 is 15, so you have 15 over. Now this total is not going to be the same. Why? Because 1 has been selected before, so the total is remaining 19. Okay, so you have 15 over 19. Okay, now plus probability of picking red is 7 over 20. Then probability of not picking red is 20 minus 7, that's 13, divided by, but the total is going to change now, so 20 minus 1, that's 19. Okay, then plus probability of picking yellow, 8 over 20 times probability of not picking yellow. You have 20 minus 8 is 12 over 19. Okay, now multiplying that out, we're going to have 5 times 15, that's 75 over 20 times 19, 380 plus 13 times 7, 91 over 380 plus 12 times 8, 96. Okay, 96 over 380. So we have 96 plus 91 plus 75. That will give us 262 over 380. Now reducing this to the lowest term, you have 2 into this is 131 divided by 2 into this is 190. Okay, now that's the probability of picking 2 sweets at random but not the same color. Okay, so that's all you need to know about probability. The basic thing now is that always know that a full-time probability, okay, of something occurring is 1. So if it's not occurring, that means it's not 1. Okay, then you could always work from there. That's all you need to know about probability.